Hey there, welcome to Chapter 2. This is the first section, 2.1, where we're going to talk about relations and functions. To begin with, we have to talk about domain and range, how we identify them. Those are two terms that from here through the end of our school year, we're going to be talking about domain and range a lot. So let's get used to those. Then, what is a discrete relation? How do I determine if a discrete relation is a function? And then if it is a function, how do I classify it? So there's lots of terms that we're going to be talking about in the very beginning. So you may want to go back and listen to this first part one more time. But I am really convinced that you guys can do this. So let's get underway here. All right, domain. Domain is a relations set of inputs. Okay, inputs. Another way of saying inputs would be x-coordinates. X-coordinates. The range is the relation set of outputs or y-coordinates. You might think of them as y-coordinates. A relation is any set of ordered pairs. When you have a discrete relation, okay, it includes only the points that you are told about, that you are listed. Nothing between, nothing between. There are many representations of a discrete relation. You can use a mapping, and I'm going to show you examples in the next slide. A mapping, a graph, like on a coordinate plane, but the points are unconnected, right? There's no line segments attaching. No line segments. Okay? Or we can have a table of values or ordered pairs. But the kicker with this is that there's no equation associated. It's not associated with an equation, which means that somebody just gives you a set of ordered pairs, or somebody just gives you a table of values, and you don't know the equation associated with it. All right? And then a discrete function, the keyword function, is a relation. So every function is a relation, but it's very specific. The x-coordinates must be different. You cannot have any repeating x-coordinates. Once you determine you have a function, you can classify, and we're going to do lots of examples of this, so don't be worried. Okay, it's classified as onto when every y goes back to an x. Now, if you think in terms of ordered pairs, you think, well, when does that not happen? Most of the time, you will not be onto in a mapping situation, The other classification is one-to-one, which means that no y's repeat. So a function is when no x's repeat, and a one-to-one is when no y's repeat. So we don't have any duplication of y's. All right? These are the four representations of a discrete relation, mapping. With a mapping, you have the left-hand column here. These are going to be your domain, your inputs. You can think of them as the x-coordinates of an ordered pair. So an ordered pair would be 1, 9, 2, 8, 3, 7. See how you can think of them? 1 goes to 9, 2 produces an 8, 3 produces a 7. This column here is your outputs, which we think of as the range, or you can think of as the y-coordinates. Now with a graph, this is the next representation. We're used to seeing this. Your x-coordinate is your domain or your input. Your y-coordinate is your range or your output. Very simple, just like what we have done before. Now 3 and 4, notice the criteria is that there's no equation associated with this table of values, okay? You're just given this table of values and not told anything about how the points were derived. So your x's are your domains or inputs, your y's are your range or outputs, okay? And again, with ordered pairs, again, no associated equation. You haven't generated anything from an equation. The first term, like what I put in red, those are your domains. Your second coordinate, The ones in blue are your range. Okay, so let's kind of go through some examples of discrete mappings. Okay, they want us to list the domain, state the domain, state the range, decide if it is a function, and then classify it as onto. Remember, every x has a y. One-to-one, meaning no y's repeat. They can be both that or neither that. All right. So in this first example right here, here's where I'm at. Our domain, we're just going to list out the x values here, 1, 2, and 3. The range are the set of numbers 7, 8, and 9. Okay? Is it a function? Well, yes, because every x is different. So I just write x's are different. And then we have to classify it. Does every y go to an x? Yes, so it's on to. And is every y different? Yes, so it's 1-to-1. This would be a both. Okay, I don't have room to write both, but write down both. Okay, the second example, our domain. Whoops. Our domain is 1, 2, 3, and 4. Okay? The range are the values 7, 8, and 9. Is it a function? Well, every domain value is different. Only one arrow, one line coming out. So this is yes. And the x's are different. X is different. And then we have to classify it. All right. So does every y go to an x? Yes. So it's on to. Every y has an x. And then is every y different? Well, if you notice here, I have 2 x's going to 7. All right, 2 x's going to 7. So this is just on to. It is not 1-to-1. Right? This third example, I have 1, 2, 2, and 3. See how there's 2 lines coming out of the number 2? All right, you don't have to write both of them, but in the beginning it makes it helpful for you to see. The range is 6, 7, 8, and 9. Is this a function? Well, look how we have 2 lines coming out of the 2. That's like saying we have the ordered pair 2, 6 and 2, 7. See how the x's repeat themselves? That means this is not a function. And if it's not a function, we don't have to worry about classifying it. All right. Now we're going to do the same type of thought process with the table of values. State the domain, the range, decide if it's a function, then classify as onto, 1-to-1, both, or neither. So my domain here are the x values, 0, 1, and 2. The range are 1, -2, 5, 6, and 8. Is this a function? Yes. All my x's are different. And then I'm going to classify it. Does every y go to an x? Yes. So it's on to. Is every y different? Yes. So it's 1 to 1, so this would be both. And if you want to write onto and 1 to 1, that's okay. All right. In the second example here, my domain, I list out all my x values. So I have 2, -1, -2, -1, and 2. My range are the numbers 1, -2, 5, 6, and 8 again. Is it a function? No, because -1 repeats and 2 repeats. So I have x's repeating, and then I don't have to classify it because it's not a function. Okay. This last example on this one, the domain again is -2, -1, 0, 1, and 2. My range is 1, 6, 5, 6, and 8. All right, you don't have to write the 6 twice, but it helps you see what's going on. It is a function because my x's are different. Classifying, every y has an x, so that makes it onto. But some of the y's repeat. Some of the y's repeat, so it is just onto. It is not 1 to 1. So that one is just onto only. We can do the same thing with ordered pairs as well. State the domain, range, decide if it is a function, then classify as 1 to 1, onto, 1 to 1, both, or neither. So the domain, that's the x coordinates. 3, -4, -4, -1. The range, 2, 5, 9, 1. Is it a function? No, because x's repeat. We can't have that. It's still a relation, but it is not a function. And then we don't have to classify because it's not a function. We're classifying the function. All right, on this one, our domain values are the x's. Domain, 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 domain. All right, so it's -6, -5, -3, -1, and +6. The range is -1, -9, -7, +7, and -9. Okay, so we have a repeating of our y's. That's something that we need to pay attention to. Is this a function? Yes, the x's are different. Okay, classify it. Every ordered pair has a y, so an x and a y. So that means it is onto. But these y's repeat, so it is not 1 to 1, so it is just onto. Finally, in graph form, all right? So basically, we're going to state the domain, the range, decide if it's a function, then classify as onto, 1 to 1, both, or neither, okay? So another way with a graph that you can decide if you have a function is to draw a vertical line. This is the vertical line test. So go through every point. If it only hits one point, then it is a function. If it hits more than one point on that line, then it is not a function. All right, so my domain, this is 1, 2, 3, 4, is -4, -3, 1, and 4. My range is 2, -1, +2, -3, and 0. Is this a function? Well, no, because look at this. It doesn't pass the vertical line test. vertical line test. If it's not a function, then I don't need to classify. On this final example, I'm going to drop it to see if I have a function. Looks like I do. So my domain are all my x coordinates. So I have -4, -1, 1, 2, 3. My range is 2, and again 2, and again 2, and then a 4, and then a 1. So yes, it is a function because it passes the vertical line test. Classify it. Does every y have an x? You betcha. So it's on 2. Is every y different? No, every y is not different. These all have the same y values, so it's just on 2. All right, this is going to be the daily assignment we work together on tomorrow. So I hope this was clear. Go over those initial definitions and get started early on the Quizlet for this chapter because there's a lot of words in this chapter. I know you can do it. It's going to be a great chapter, so I'll talk to you soon.